Hello, good morning everyone, especially to dear judges and all my peer research. Okay, my name is Aisha binti Ahmad with the ID of RE014 and my title of the research is Next Gen Drilling Innovation Drilloptimax Data Driven Breakthrough for Aircraft Manufacturing. I've come from Faculty of Mechanical and Manufacturing Engineering from University of Tun Hussein. Alright, a bit of introduction. What is Drilloptimax? It's a revolutionary tool for data-driven optimization and also predictive maintenance capabilities, where it's an innovative software tool designed to optimize the drilling process used in aircraft component fabrication, where it leverages advanced data mining algorithm using these three clustering methods: K-means, K-median, and hierarchical clustering. By analyzing the drilling data, uncover patterns and recommend process improvement. So a bit of project description on what is Drilloptimax. It's transform drilling into a smart data-driven process for the aircraft industry. It analyzed the surface roughness, circularity, and centricity, where it advanced clustering methods to classify hole quality and reveal critical insight and to process behaviors. So using this, engineers can now optimize feed rate, spindle speed, and tool path with confidence, supported by machine learning validation. This is proven using 300 hole on aluminum 6065 trials. It reduced rework, cut material waste, and accelerate inspection. And it also a breathtaking platform that paved the way for predictive and autonomous drilling by shaping the future of sustainable, precise, and efficient aircraft manufacturing. It have a few objectives, and number one is by improving manufacturing precision. It also optimize process efficiency and enable predictive maintenance, and also enhance quality control and also reduce manufacturing costs. In terms of novelty and inventiveness, Drilloptimax introduced the next generation integration of multi-metric clustering, unsupervised classification, and predictive analytics specifically tailored for aircraft drilling operation. Unlike conventional inspection method, it simultaneously evaluates surface roughness, circularity, and centricity through a unified clustering framework, where it will enabling holistic assessment of hole quality. It's also using parameter window discovery by identifying the optimal drilling ranges for accepted outputs, while confusion matrix validation ensure the reliability by minimizing false positive and false negative, true positive, and also true negative. And using the spreadsheet integrated workflow makes advanced analytics accessible to engineers without requiring specialized coding expertise. And finally, by incorporating the predictive tool where analytics position, the Optimax not only act as a diagnostics tool, but also as a forward-looking platform for autonomous data-driven manufacturing. So this unique combination of multi-parameter intelligence, validation rigor, and predictive foresight distinguish Drilloptimax as a pioneering breakthrough in precision drilling for aircraft manufacturing. So the experimental setup began with the analysis parameter, where we are going to drill a hole diameter with 10 mm with it. Cutting speed 31.4 m per minute. With the feed rate varied for each workpiece, 10 different feed rates, starting from 0.1 until 0.36. And the measured outcomes on the surface roughness, centricity, and security were in the industry standard 0.8 at the 0.6 is the industry standard. We will apply clustering method using MATLAB. Using these three clustering methods, K-means, K-medoid, and also hierarchical clustering. And also we will evaluate the algorithm performance using conversion matrix and its key metrics on the accuracy, precision, recall, and so F1. And it will come up with the result where the K-means outperform the others with superior F1 score. It has a high correlation between all evaluation metrics, validating model consistency. And from the 3D scatter plot, you can see the rejected holes on the clustered region with high surface roughness and circularity, where on the accepted holes blue concentrate at lower surface roughness and circularity. On the bar plot, at 0.33 mm per revelation, acceptance rate was about 6.67%. On a line plot, rejected holes at 0.33 mm per revelation show notably higher surface roughness, and the box plot cluster 0 rejected displayed a wider spread in circularity and surface roughness, indicating unstable. On its creativity and delivery, we have the multi-metric fusion, where we combine multiple metrics into a single framework, revealing hidden insight. It also have a sensor-free analytics, where it leverages post-process measurement data, avoiding extra hardware and lowering adoption barriers. And we have spreadsheet to insight, where transform Excel upload into clear class and parameter guidance. And lastly, it has a metrology to intelligence, where it turns routine QC data into actionable process improvement. On the commercialization, we will have a trial demo where it's providing free access to a showcase to the product, and also offering an analysis as a service, offering analytical service for a fee, and education use, where it will be utilizing the product in academic projects. For competition expos, we will be showcasing the product in events and partnering with small CNC shops for small CNC shop collaboration. And lastly, we will have a basic grant application for funding to support the development. In terms of benefits to society, by enhanced aircraft safety, by ensuring high drilling precision and reducing structural defects. Drilloptimax strengthen the safety and reliability of aircraft component, protecting passengers and operators. It will also reduce material waste, where data-driven optimization minimize rework and scraps, contributing to sustainable manufacturing and responsible resource use. Apart from that, it will also increase energy efficiency, where optimized drilling parameter reduce machining time and energy consumption, lowering the environmental footprint of aerospace production. And innovative in aerospace, the system accelerates the adoption of smart manufacturing of Industry 5.0 or 4.0 or 5.0 practice, pushing the boundaries of aircraft innovation. And lastly, it will going to have a job creation, where new roles in data analytics, process monitoring, and advanced manufacturing are fostered, creating opportunities for a skilled workforce. And lastly, for technology transfer, this method and tools developed can be applied across industry, driving broader industrial competitiveness and technological progress. For Sustainability Development Goals, we have Sustain SDG 9, 12, and 13. On this SDG 9, we're going to promote sustainable industrialization through advanced manufacturing techniques. And for significantly reduce material waste in aircraft manufacturing for SDG 12, and for SDG 13, it will improve energy efficiency in manufacturing process. For technology readiness level, it has TRL 4, where it has been identified technological components and it was recognized for integration, integrated into low fidelity system where components are combined into a basic system, and demonstrate core concept. The concept is proven in a lab setting and test individual component where components are tested separately for functionality, and achieve primary integration where components are integrated to show potential. So for IP patent, it has IP number P112024003707 with the title Drilloptimax Advanced Analytics Driven Drilling Optimization System for its aerospace manufacturing, and it has research grant MDRH510. On benchmark, it was benchmark between Drilloptimax and Smartball, where Drilloptimax won in the data source and focus, hardware requirement, and analytical insight provided. For fabrication current trend in drilling, the contribution of aircraft component to aerospace revenue were approximately 55 until 60% of aircraft manufacturing cost is attributed to its component, including precision parts like drill hole, fastening, and structural assembly. So where Russia's industrial fasteners market growth is projected to surpass $2 billion by 2029 and driven by demand from sectors such as heavy machineries, automotive production, and infrastructure development. And its impact on drilling defects on aircraft component rates up to 35% of reworks in aircraft component manufacturing are due to drilling related to defects such as poor surface ramps and dimensional inaccuracies. So here is the architecture and the diagram where it has a shop floor connected to a server where the user can will collect data, and the data will be pushed to for manufacturing process, cyber physical system, modeling, and big data analytics. In terms of awards, it has won a few awards, and the latest it has won Gold Award on iDrive and also on RISE 2025. In terms of publication, it has we have published book and a few journals and also a few conference participated, and we have the mock-up screen that we have developed where we can just upload the data using Excel, and then it will analyze using clustering methods, and it will analyze the clustering analysis and visualize the results. Thank you.